Okay, can you see my screen? Very good. All right. So last time we started talking more about lists. I mean, we've been, covering lists extensively. So we're gonna continue talking about lists. So if you remember the last time we talked about, basically cloning and aliasing and how, once you reference a list with another name, this might, like both would refer to the same object and how we need to be careful with this. We'll play with this a little bit more, but let's start with something slightly new. So we have the following. We have something called list of lists, right? And that's, again, you have to be very careful about this when you're doing mutation or aliasing, right? So I can have elements inside the list that are lists themselves. Let's see how. Here's an example, just a little bit different from the slide, and then we'll do the example in this. So I'll do Python, and then I can say L is equal to, if I do 1, 2, 3, this list has 3 elements, which happens to be integers, 1, 2, and 3. Okay? Now, if I say L of 1, that would give me the element 2, right? Because 2 is at position 1 in this list. Okay, but I could also define list L to be, a list of lists. So I have 1 and 2, that's the first element, comma, 2, 2 and 3, that's the second element, and then 4, okay? So the question for you, if I type in length of L, right? Look at L now, it has these elements, right? So I have, a square bracket, and inside of it, another square bracket, which contains some integer, and so on. What is the length of L in this case? Anybody? Nabil is saying it's 3. Okay. 3, so I add, okay. Joseph is saying so I add 3. Okay, great. Yes, it's 3, right? So L of 1. If I index, right, the element at position 1 in this list, what does it give me? Two and 3, okay. So Joseph is saying 2 and 3. That's correct, right? Because 2 and 3, the list itself, is the second element in the list L, right? So this is what is called a nested list, a list of lists. You can do this any number of times you want, right? So you can have a list of a list of a list and so on. Okay, let's say L of 2. What is L of 2? That's 4, as Saad's saying, and Muhammad, correct. All right. What is L of 0 of 1? So look at this, right? Now I'm doing double indexing because I know, right, that some of the elements inside the list is a list itself. So I'm saying give me L of 0 and then another index of 1. So it's gonna execute it this way. First does L of 0, returns its value, and then whatever L of 0 is, it will do index at 1. So Saad is asking, is it 2? What do you think, right? Adam is saying it's 2, Fadi is saying it's 2, it's correct, it's going to be 2, right? So that's L of 0 is this one, it's a list, and then I'm saying, get me the 1, right, element at position 1 of L of 0, okay? And if I have, 2 nested lists inside of each other, I can do 3 times index, and so on. Okay, final one, length of L of 1. Okay, so Muhammad is saying 2 also, that's correct. Why? Because L of 1 is a list and it has a length which is equal to 2. All right, last one, length of L of 2. Any thoughts? length of L of 2. 1, okay, okay. So Joseph is saying 1, Mohammed is saying 1, Adam is saying it's not a list. This will give me an error, right? Why? Because the element of position 2 or the third element in list L is an integer, right? We cannot do a length of an integer. Yeah, so that's correct. It's going to give me an error. It's not a list. Yeah? Because here the second element or the element of position 2 is not a list. So I cannot do its length. Perfect. Okay. So I'm going to clear and we'll start with the example in the slide. Okay, so we need to be careful about aliasing and right mutation when we talk about list of lists. Why? Because it's going to be one object in memory that can be referenced in different places. So I have few, right? Similar to the last time we did, I have few lists and I'm going to play with it. The worm is equal to yellow and orange. It has 2 strings. So that's my list worm, right? The length of worm is 2. And now I have hot is equal to. So hot is a list that contains one element only, which is red, okay? Then I'm gonna define another one called bright colors. That's its third list. And I'm going to say it's this. Okay, so it's a list of, whatever is inside worm. Okay. If I print bright colors, what do I expect to see? I expect to see double squares, right? It's a list of a list, right? And it has exactly one element. So basically, bright colors has just one element, which happens to be a list itself. Yeah. So if I do length of bright colors, what do I get? Do I get 2? Do I get 1? So I'm saying 2, Ferry saying 1. Who says also 2? Who says also 1? I want to hear from other people. 1, okay. Anybody else? Adam? No, I'm not keeping track of all the names. Adam's saying 2, so Adam's saying 2. Okay. Again, what is inside bright colors? Look at it, right? It's 1. Why? Because look at bright colors. What does it have? It's a list, and inside of it, there is one element, right? Which is another list. That's worm. Yes, worm has 2 elements, yellow and orange, but inside bright colors, it just sees one object, right? Which is a list. Yeah, so it sees, one element. So that's going to be the length is 1. Okay. If I do, of course, length of bright colors of 0, as you guys said, it's going to be 2, right? Because I'm saying, okay, get me the first element in bright colors, right? That's, yellow and orange. And then out of this, try to, see its length. And that's going to be 2. Yeah, I know it's tricky, but you get the hang of it. And this is, you can always try this out. Yeah? So you don't need to memorize this. Okay. So I'm going to do the next thing, which is bright colors dot append hot. Okay. Let me just see if there are people who are trying to get inside. Okay. So what I did right now is I had bright colors, had one element only, which is a list with 2 colors. And now I said bright colors would append hot. What is inside hot? Hot has just one element, right? It's a list that has one element, which is red. Okay. If I print bright colors now, so it has changed, right? So bright colors would have 2 elements. Each one is a list. The first one has, is a list of 2 strings. The second one is a list of 1 string. What is length of bright colors now? Look at bright colors, right? This is it. And tell me what its length. Nabil is saying it's 2, Daniel 2, Joseph 2. Excellent. Yes, it has 2 elements. First one is a list, second one is a list. All right? So really has 2 elements. Okay. So far, so good. Okay, now I say the following: hot.append pink. Okay. So look at hot. What was hot the last time I defined it? Was, a list of one string only, red. Yeah. Now I'm saying hot.append pink. Okay. So add to, the list of hot, another element called pink. If I print hot, it's going to be two elements now, red and pink. Okay. Now, what do you expect to happen when I print bright colors? So it was before, the last time we printed bright colors, it was this, yellow and orange and red. And then I appended hot and red. That's fine, Rawat. Right from now on, lectures are going to take place on Zoom. Please follow, my announcements on Moodle. I sent you an email. Please check your email as well. Okay. So what is bright colors right now, right? It was before yellow and orange, right? Two elements, each is a list. First one is yellow and orange, the second one is red. And now I appended something to hot, and the question is, would bright colors change as well? Okay, so Rawad is saying, no, it wouldn't change. Rawad, you weren't here to, follow the previous discussion. Joseph saying it's gonna change. So what do you think, guys? Other people? What did I do? I had, right, let's follow again. I had defined warm at this, hot at this, and then I added warm inside something called bright color. So it had one element, which is a list. Then I added this other list. Then I updated this guy. Would bright color change or not? Okay. So some people are saying it changed. Some people are saying it will not change. The correct answer is it's going to change. Why? Remember when we talked about aliasing and cloning? Yeah, we have one drawer where we define the list in it, and then every time I reference this list, I just open the same drawer. Let's see it in the diagram. Here's how it looks like. Right? So I define war. That's a pointer to a place in memory, which contains all the elements inside the list. It has orange, red, and yellow. Why orange, red, and yellow? Because first, right? Sorry, I went to another slide. Sorry. Yeah, here. I had war, which contains yellow and orange. Right? That's because I defined it this way. Right? War is equal to yellow and orange. So that's going to be the thing, right? Remember, right? So if I have a drawer and I add a sticky note on it called war. And then I say hot is a list which contains red initially, right? Like that. And then I say, okay, at some point, append pink to hot. So now, I open the drawer where hot is and I put pink inside of it, okay? Now, bright colors has, two lists inside of it as elements. That's the first element, and that's the second element. And they're going to be references to the same drawers, right? So basically, they're pointing to the same drawers. Why? Because again, right, when I clone, when I reference a list or an object, right, it's the same. Yeah. So if I'm doing alias, if I change hot here, it's going to reflect everywhere. I'm not doing a copy of it. Okay, so this is like extending a list, but using a variable rather than a hard-coded list. I'm not sure what you mean by hard-coded list. It's really reference, yeah? You reference an object. If you change it, it's going to change everywhere. That happens with lists, with tuples, with, all sorts of objects, as you would see, okay? So be careful about these things. Questions? Again, you'll get the hang of this by practice, so don't worry too much, but it's something that causes bugs in your program because you expect, right, you do a change to an object like a list, and then it, changes everywhere, and this is not intended, and that causes, some issues. So if you wanna, right, change something, and you don't want it to reflect everywhere, you have to make a copy of it, right? Clone it, basically. That's important. Okay. Hard-coded means, right, like something that is stored, when you say hard-coded, you mean, right, like something that is stored explicitly, yeah? like it's a general term, but like it doesn't make, it doesn't have a context here. Yes, it's also recorded. You can look at the recording. No, there's no issue at all. We didn't say anything new. We just talked about list of lists, so it shouldn't be a problem. Okay, let's look at another exercise that's gonna kind of stress this in your heads. Okay, so mutation and iteration. Right, we're gonna talk about an example, a very simple example. I give you two lists, L1 and L2. And what you want to do is you want to remove, right, the elements that the intersection, right? So remove every element that is in L2 from L1. So for example, right, I have these two lists. List 1 has 1, 2, 3, 4. List 2 has 1, 2, 5, 6. I want to write a function, remove duplicates, that reads these two lists. It sees, oh, 1 appears in list 2, then remove it from list 1. And then 2, oh, it also appears in list 2, so remove it from list 1. 5 doesn't appear, so I'm not going to do anything. 6 doesn't appear, so I'm not going to do anything. So basically, I'll end up with 3 and 4. I'm really sorry for that. It's probably Suad from your internet connection, because I believe, right, Zoom is much better when it comes to lagging, as far as other people have been telling me. Okay? Okay. Let me see. This, okay. Is this better now? So I'm at AUB. I don't know what else can I do. I mean, this is supposedly the best internet connection in the country, or at least in that is accessible to me. Now, is it better? Oops, sorry. Okay, good. So let's try again, right? So here is where I am at right now. I want to write a function that takes two lists, L1 and L2, and removes, right, any elements that from L1 that appear in L2. So I give you 1, 2, 3, 4. I want to check 1, does it exist in L2? Yes, then remove it. 2, does it exist? Yes, remove it. 3 doesn't exist in L2, so I'll keep it. 4 doesn't exist in L2, so I'll keep it. So far, so good? Okay. So now here is my function. It's loops, right? It's very simple. It loops over the following, right? It loops over the elements in list L1. And then, so for E in L1, that means, go over every element in L1. And then check, is this guy in L2? So this function, E in L2, right, this expression, returns a Boolean. True if E exists in L2, and false if it doesn't exist in L2. And then I'm going to say L1.remove of E. Yeah, so if this guy E exists in L2, like 1, remove it from list 1. Remember the remove function, it mutates the list by removing an element. So Adam is saying, so it prints 3, 4, 5, 6. No, it's not combining the lists. Look at the code, Adam, right? The code does the following. Loop over every element in L1, check if it exists in L2. If yes, it removes it. So it's not combining the list, right? Otherwise, I would do concatenation. What I'm doing is just see if, right, an element exists in L2. How does it know what E is? That's a loop, right? So I'm looping. So for every element in L1, what is for E in L1? It means loop over all the elements in L1. So I have 1. I start with 1. Check is 1 in L2. Yes. So remove it. And then I go to the next element. It's a loop, right? Starts from the beginning, from position 0 till position 1. No, Adam, right? It doesn't change L2. Does it change L2? I'm only removing from L1. Why would L2 change? Look at the function again, right? I'm saying, okay, if E exists in L2, remove it from L1, right? So I'm not changing L2 at all. Other question? Okay, so I'm gonna show you the code and let's run it. Can I cut this for now? Here's the function as exactly as. Okay, so why is it impossible? We have talked a lot about lists are mutable. I can change them. I can do anything I want. In fact, every time I do append, I'm changing the list. Every time I say, you know, L of 1 is equal to a value, I'm mutating the list. Yeah. You can mutate the list, right? Well, it doesn't matter, right? I'm passing it, first of all, I'm passing it as an argument. That's the first thing, right? So here, I see what you're trying to say. You're saying, okay, these variables are not defined, right? But I'm passing them as arguments here. Saying, okay, pass L1 as an argument and L2 as an argument. I can change it, right? Like passing an X, remember? Pass a variable, X, and then I can change it inside. So that's no problem. What if we say remove duplicates of L2 and L1? It will do what? It will do, right, loop over these guys. So check, is 1 in L1, right? It will replace, basically. It will understand that L1 that you passed here is L2, and L2 is L1. Got it, Ali? So it really takes, right, whatever you pass. So here, since you passed L2, it will assume that, you know, L1 here inside this function is actually L2. So it will loop over these elements, check if they exist here, yes or no, and then remove the ones that exist in L1. So it will end up supposedly giving you 5, 6. Okay. But for now, let's focus on the example way. So I have the function here. I have the list L1 is this, L2 is this, and I'm gonna say, you know, remove duplicates of L1, comma L2, and then I'm going to print L1 to see if it actually removed the duplicates. Okay? All right, let's run. So L1 is as before, 1, 2, 3, 4, as in the slides exactly, and L2 is 1, 2, 5, 6. Okay, Control Z, clear, and then I'm gonna do Python duplicates.py. Okay, so what do you expect to see? Can somebody tell me again? Three and 4. Okay, so Adam's saying 3 and 4. And that's what it prints, 2, 3, and 4. So supposedly it should remove, right, 1 and 2 because they exist here, but here it printed 2, 3, and 4. So it did not remove 2. Any thoughts why? This is slightly tricky, or, you know, I doubt, right, you will be able to figure this out on your own, but let's see here some thoughts. Why didn't remove 2? Yes, exactly, that's the question. Any thoughts? Okay, let's understand why didn't remove 2. Okay, why? Because of the following, right? Python uses an internal counter. Yeah, I mean, I haven't discussed that. I'm just asking. Yeah. E is only one value. No, it's a loop, right? It goes through every element. What happens is the following. Listen. Yeah. So here, right, Python keeps an internal counter to keep track of the index it is in the loop. So it starts with, you know I'm in E. The first element that E is gonna take is 1. Right? So it has 1, something similar to what Rawad is saying. So it has 1 right now. Okay, so far. So I'm gonna try to annotate. So E starts, right? The first loop here, E is gonna be equal to 1. Right? That's the first element in L1. Okay. Right? And I know that L1 is 1, 2, 3, 4. Okay, so now it goes here. Is 1 in L2. So it's gonna check 1 is in L2? Yes. So it's gonna get inside here and it's going to remove this element. Okay, great. Now I'm going to this next element in the list, right? So I want to go to the element at position 1. I started with element at position 0, right? So that's where I started. Where is the annotation? Yeah, okay. Okay. So I started at position 1, right? So basically I have an index. I have an index here, right? So I was at position 0, right? When I say E, right? So I am at position 0, okay? So that's why I got this element, okay? And now I did, right? Check 1, is it an L2? Yes, so I removed it. So I removed it from the list, okay? Now I'm at position 1, okay? And the list is 2, 3, 4. What is the element is at position 1 in list L1 right now? So L1 is 2, 3, and 4. So what is the element? It's 3 exactly, right? So now it sees, right, that the element is 3. So it's gonna go to here, right? And it never sees 2. 2 is never seen. Why? Because I'm mutating the list inside the loop, right? And that's disastrous. You cannot mutate a list inside a loop, right? So basically, it's gonna see 3 next after the 1, and it has never seen 2, and that's why it will keep 2 inside. Again, let's try to analyze this again from scratch. Okay, so I'm gonna start with the following. Okay, and then I'm gonna start, right? The first thing here inside this loop is I'm going to initialize an index, right? So I is equal to 0, right? So for E and L, so what is E then, right? It's the element at position 0, that's 1. I'm gonna check, is 1, right? Inside L2, yes. So I'm going to remove 1, okay? Then I'm going to increment this to be 1. Check, what is E at position 1 in the current list? The list now has 2, 3, and 4. That's this element, right? That's at position 1, right? So E would be equal to 3. Is 3 in L2? No. Then it's going to move, right? This I would be 2, right? So the element would be 4. It's 4 in list L2? No. And then it's going to end, right? Because I finished the list, okay? So basically it will end up with 2, 3, and 4. I just repeated email. Yeah, so how do I make sure, right? We'll fix this right now. Yeah, the issue is the following. The issue is I'm passing, right? I'm looping over L1 and mutating it at the same time. This is a recipe for disaster. You cannot do that, right? So if I try to, let me just clear. Okay, close this. And now let's see how do I fix this. So I'm going to fix it this way. Here's the function I'm going to write. Can you see now my Visual Studio? Okay, great. So here's the function I'm going to define. It's called remove duplicates new. Takes again two lists as arguments, L1 and L2. What did I do here? I said copy the list. How did I copy it? By doing cloning, right? So L1, and then 2 columns like this means take a copy of L1. So in memory, I'll have 2 objects, right? So basically in memory, I would have something like, L1, and I have L1 copy. Okay. 2 objects different, right? All of them have the same elements. So this one has 1, 2, 3, and 4. And this one has, because I did cloning, right? So this one also has 1, 2, 3, and 4. Okay. Now I'm looping over the copy. So start with this element. Okay, 1. Check, is it in L2? Yes. Remove it from L1. So I'm looping over the copy, right? So is 1 in L2? Yes. Then remove it from L1. So I'm going to remove this one. Okay. Now what's the next element in L1 copy? It's 2, right? Is 2 in L2? Yes. So remove it from L1. Okay. Then what is the next element? 3 is 3 in L2? No. 4 L2? No. And so it would work fine. So if I clear, if I now do right, instead of this, remove duplicates. And I run it, it should work as expected. Okay, here it is. Python UI, and it as explained. Why the counter updated here? Why is it updated correctly here? Because I'm looping over the copy, Christina, right? So I'm really working on the copy. I'm removing from one list, but I'm looping on another copy of it. Yeah, so I'm not mutating the list that I'm looping over at the same time. Yeah, that's the only difference. So here I'm looping over the copy, and the copy doesn't change it throughout. I'm not changing the copy throughout the loop. I'm changing the actual list L1. Yeah, so that's why it would work. Try it out, after class, and see, try with different elements and see what really happens. We can change the list and see what happens. Okay. Other questions? As you see, no, it's not, right? Again, when I do, the only difference here, if I had said L1 copy equal to L1 without this, this thing, then they would be exactly the same thing, right? They're exactly the same object in memory. But here I'm saying make a copy of it, right? So as if you have two different drawers, one for L1 copy and one for L1. If I change L1, that's not going to reflect an L1 copy because I'm doing cloning here. Okay, so this is cloning, right? Yeah, that's okay. Not sure I get your question, Robert. So what do you mean by this? If you have more duplicates, right, this would work, all right, for any number of duplicates. This is a general problem that takes two lists, remove the duplicates from the first list. That would work no matter how many loops you have. The only issue is the following. You cannot, change a list that you're looping at the same time. This will cause a lot of issues, right? If you want to do this, take a copy of the list, loop over it, and change the original list. That's the whole point of this slide. Try it out and see what you get. Okay, let's do another example, and again, right, just try it out offline, and we can discuss this on Friday. We have time, so we can discuss this Friday once you try it out by hand. Okay. Let's see, what do we have next? Okay, here's another example. About scoping and changing of lists. Again, all of these things you have to kind of give it a try by hand. So let's say the following. I want to write a function that takes a list L and doubles the number inside of it. Yeah, so basically it takes a list L and then just, it's a list of integers, and then it would, double the elements inside of it. Okay, so I have the function here, takes as input, as an argument or parameter L, loops over the elements inside L, multiply them by 2. Yeah? So basically updates Li to Li times 2. Okay. So let's see the following. I have L is equal to 1, 2, 3, 4, and then C is equal to double list 1 of L. And then I print L and I print C. Okay. Can anybody tell me, right, what is going to be printed? So print L, what is it going to print? And print C, what is it going to print? So here I said L is equal to this, a list, and C is equal to, pass this list L as a parameter, multiply the values by 2, and then return this list and store it into C. What do you think is going to happen to L and to C? What is going to be printed?
Are you talking about the first case or the second case?
This exactly. This follow this code on the left, right? I have the function here.
Oh, on the left.
Yeah. L1 is equal, L is equal to 1, 2, 3, 4. C is equal to double list of 1. Print L, print C. Adam is saying C is going to be 2, 4, 6, 8. Correct, right? Because I'm returning, I take this list L, update it here by multiplying every element by 2, and then I return L. So C is going to be 2, 4, 6, 8. What about L?
It's gonna give 1, 2, 3, 4, 2, 4, 6, 8.
I don't understand the question. So repeat, please.
Is that a question?
The answer? What is L? What is it going to print L?
1, 2, 3, 4, then 2, 4, 6, 8.
Okay. So Adam is saying the same, or I think Child is saying the same. So for L, it's going to stay the same. For C, it's going to be 2, 4, 6, 8. Anybody has a different opinion? I'm passing L. It doesn't matter. I'm passing right L here. This is capital L, but I'm passing this L as an argument. So L is going to be equal to this L, right? Loop over, right? So inside, once I get into this function, right, this capital L is going to be 1, 2, 3, 4. Okay, so it doesn't have to be the same value. It can be X here. I can pass a list called X. It doesn't have to be exactly the same. Okay. So, but the question is, right, whether if I pass this as an object to a function, change this object, does it make a copy of it inside the function, or it's referring to the same object? What is the issue here? I am passing a list called L, uppercase L. I'm doing a looping over this list, L, uppercase L. Yeah, you're saying here this has to be capital L. Yes, you're right. Yeah, there is a typo here. Okay, let's see this code on the screen. Yeah. So, right, I'll start with this one, the one in the slide. Okay. So I have, right, pass L as an argument for I in range of length of L, L I times 2, and then return L. Okay, let's see what it's going to print, and then let's discuss why. And okay, so Python. Okay, and it prints L, right? So L is 2, 4, 6, 8, and C is 2, 4, 6, 8. Any thoughts why? So it updated both L and C. Why? Because once I pass, again, right, this is an object, it's one place in memory, so all of them would refer to it, right? So once I update this L, I pass as an argument, I update L here somewhere, it's going to reflect in both of them, right? So basically, right, it's the, like if I look at the memory, I have L, right, and I have, right, it has 1, 2, 3, 4, right? So that's how it looks like in memory, right? This L here, right, inside the method is going to point to this guy, right? So just I pass a reference, right? So it's going to point to this guy. It will update this to be, 2, this to 4, this to 6, and this to 8, right? And all of this is reflected in L. And then I'm returning this guy. So this would be returned to the caller. So C would point to the same list here, and both L and C are updated. Here you passed L as an argument, isn't it just a parameter? Yes, but again, when we talk about objects like lists, strings, stuff like this, so not numbers, not values like integers, floats, Boolean, what is going to happen is it's going to pass, all updates will happen. It's passing, the location in the memory. It's passing which drawer this object exists in, And then any updates you do will be updated. There's one drawer for L, right? And when I pass it as an argument, I'm just passing, the sticky note for this drawer, right? So where is L in memory? It doesn't pass a copy. It passes the object, a reference to the object itself. Yeah, that's why whenever I change it, it reflects the changes everywhere. Okay? Let's do it, right? Because some people are confused about this. So I'm gonna do it uppercase L, or even X, we'll call it X, all right? So I'm changing the whole function to X, right? And I'm saying X of I. Doesn't matter, it's gonna exactly do the same. Right? So I'm gonna remove the annotations. Close this, and let's run it, right? So I'm saying, right, past this X, it's gonna be, the same as L, update, this X, and then return the value of X. Let's see what happens. And as you see, it doesn't change a thing, right? 2, 4, 6, 8, both would be updated. Why? Because when I pass this L as an argument here called X, both X, right? So both X and L, right, are gonna point to the exact same location in memory. It's the exact same drawer, right, which has 1, 2, 3, 4. Why? Because these are objects like lists, right? So in Python, this is what happens. It doesn't make a copy unless you explicitly say make a copy. So X is gonna point to 1, 2, 3, 4. 1 is gonna point to 1, 2, 3, 4. You update X to, right, 2, 4, etc. Right? This gonna reflect also on L. I passed it here. I'm saying, double list, right? 1 of L here. That's when I passed. Correct, Christina? I passed L as an argument. I pass a parameter when I'm calling the function, right? Who still doesn't see this? Other questions? Is this clear to everybody? Okay. So if it is clear, can you tell me how do I update this? How do I fix this? I want it to change only, right? So give me a copy of the elements in L double without really changing L itself. Yeah. So clone it, right? How? How do I clone it? Correct. Yes, I clone it, but how? Any thoughts? Where I can clone it in multiple places, right? I can say here, here are a few ways to do this. Let's stop the annotation. Clear. I'll show you multiple ways of doing this. So one way is to say the following, right? To this. Pass a copy of the list. Right? So basically after that, right? That's what Saad is saying and Christine is saying. So here, pass a copy of the list. Don't pass the list itself. Right? If we run it now, it works like magic. 1, 2, 3, 4, 2, 4, 6, 8. Right? That's one way of doing it. I can also here, do the following, right? So like this. Let me show you another way of doing it is to do this. Right? Make a copy, right? So basically, just take X, or let's do it. I'll do it with you, right? So take, copy is equal to X. So clone this guy inside the function, and then for I range of, copy of I times 2, and then return copy. Okay? Either way would work. So if I pass here the L, original L, and run, should work also. 1, 2, 3, 4, 2, 4, 6, 8. Of course, the first version was easier, right? So basically, just make sure you pass a copy to the function. Right? So that's what we originally had. Okay. So here, just all I did was make sure you pass a copy. Now, what do you mean by maybe L2 equal to I for I in L1? Not sure what you mean by this. Okay, the whole point is to clone. make sure if you pass an object like a list or a tuple or a string to a function and change inside the function, it's going to change everywhere. Be careful. Yeah, if this is not what you intend to do, you have to pass a copy of it. Okay. Excellent. Right. So this is the in the slides the version that we have, right, in the thing. Right. Be careful that, right, as Rawat said, there is a typo here. So it has to be uppercase L because I'm passing uppercase L, so it has to be uppercase L. Okay. Excellent. I'll stop here, take some questions. So please, if this is confusing, ask questions. Otherwise, I recommend again, right, these 4 or 5 slides we've done today, run them one by one, make sure you understand the output very well. Yeah, so trace it with different inputs and see, what is happening. Try to guess what is the output, what is it going to print, and if you get it right, great. If you don't get it right, try to understand why it's behaving this way. This is really important. Yeah? If you want to be a serious programmer or a coder, you have to understand these subtle issues. Okay, questions? All right, just be careful. I've updated the slides and the scripts for this set a bit on Moodle. Yeah, so you might want to download the the updated slides. Also, right, don't forget that there is a typo here. So please, as you're running things, make sure you take this into consideration. Other things. Okay. Remove the removing and looping things. So the previous one, right, Maria? This one? Okay, great. So let's try to do this again. Here's the following, right? I'm passing 2 lists to the function remove duplicates. What is going to happen, right? Let's try to trace it. I pass L1. So when I see for E in L1, what happens is Python, this is how it does things, right? It starts with I, an index. It automatically initiates an index, right, which is equal to 0, right? Because any list starts at position 0. Then it sees what is the element at position 0 in L1. That's this guy, correct? So E, right, is going to be equal to 1. Okay, great. So now I'm checking, is E in L2? What is the value of E? It's 1. Is it in L2? Yes, it's in L2. So I'm going to remove it, okay? And now what happens is it updates this I, right? It increments I by 1, right? So that's the mechanism behind, right, for E in L1. It's a short notation in Python, but it gets really executed this way, right? So it starts with an index and, increments the index 1 by 1. So now I is equal to 1. And it's going to ask itself, right, what is E? What is E at position, right, 1 in the current list? I understand this annotation thing is so painful. Give me a second. Yeah, okay. So now I is equal to 1. What is the position element at position 1 in the current list? Can you tell me, Mariam? So here's the list now. It has 2, 3, and 4. What is the element at position 1? Any thoughts?
It will be 2.
So no, 2 is now, right? Remember the list now is updated. So it has 2, 3, and 4. This is at position 0. This is at position 1. This is at position 2, right? The list has been updated. So now I have, this is the first element and it's at position 0, right? 3 is at position 1. So the problem is once I say, okay, I is equal to 1, it sees 3. It looks at 3 and it skips 2 completely, right? So that's why it never removes 2 from the list. Yeah. So once I have updated the list here, right? What happens is, right, Python cannot keep track, right? It just remembers, right, that I need to look at position 1 in the current list, and the current list, now has 1 element less. So that's why this guy would be shifted to position 0, and that one would be at position. Yeah. The take-home message, if you know these details are not very clear, is the following: be very careful about how doing append, like changing lists, right, and functions. If you pass a list, right, and you change it, right, remember that these changes are going to reflect everywhere, right? And if you're doing a loop over a list and you're planning on changing it, this is disaster. Yeah. So you loop over a list, you can read things from it, you can do stuff, update another list. So take, the element from this list and put it in a new list. But if you're gonna loop over a list and change it at the same time, this is gonna be disaster. Why? Because, right, as you change things, right, the Python gets confused. Yeah? So because, right, it's really, the updates of the list, right, happens as you loop. So don't do that. Change a list inside a loop. You can always copy in another list, or take a copy of the list and change things, but do not change and loop at the same time, right? Like do not drive and drink, do not loop and change at the same time when it comes to this. Okay? All right, we'll stop here. We're over time. We'll continue on Friday talking about lists and also talk about something called tuples. All right? See you on Friday. You're welcome.